Section 9.2.17. A simple random sample of size n is drawn from a population that is normally distributed. The sample mean x bar is found to be 110, and the sample standard deviation s is found to be 10. What we want to do is be able to construct a 98% confidence interval about the mean if the sample size n is 20. So here's our formula. The lower bound is equal to the mean, the sample mean minus the critical value of t, times the sample standard deviation divided by the square root of the sample size. And the upper bound is the same thing, only we're adding that to the mean. Where again, t alpha divided by 2 is computed with n minus 1 degrees of freedom. So what we want to be able to do is construct a 98% confidence interval. So let's write down the information it's given so far. So what do we know? We know that x bar, which is the mean, equals 110. Okay, and we also know from the problem that the standard deviation, the sample standard deviation, is 10. Okay, and in part A, we also know that the value of n is equal to 20. Okay, and so what we need to do is we need to find the critical value. And that critical value is t alpha divided by 2. Okay, so in order to find t alpha divided by 2, okay, alpha, we're constructing a 98% confidence interval. So in order to find alpha, that's equal to 100% minus 98%, which is equal to 2%, which is equal to 0.02. Okay, so now that we know what alpha is, we know that that's going to be 0.02, and we're going to divide that by 2, which is equal to t alpha, which is t subscript 0.01. Okay, so what that means is that we have a bell curve, okay, and we're looking for this critical value of t that has an area of 0.01. Okay, so we know what n is. N is equal to 20. Okay, so if we know that n is 20, we want to find the degrees of freedom, and that's equal to n minus 1. And so therefore 20 minus 1 is equal to 19. So that means that we're looking for the degrees of freedom, which is 19 with an area of 0.01. So let's go down here on our table, okay, and let's take a look at 19. So here is 19, and we're looking for the area of 0.01. So there is 0.01. And so what do we get? We get a critical value of 2.539. So now we found that the critical up here is 2.539. Okay, so now what we want to do is we want to now figure out what is the lower bound and what is the upper bound. So again, the lower bound is taking x bar minus the critical value times the standard deviation over the square root of the sample size. So we know that we have 110 minus the critical value of 2.539, and we're going to multiply that by the standard deviation, which is 10. And then we can divide that, since we're multiplying those two together, divided by the square root of the sample size, which is 20. Okay, so if we plug this into our calculator, what we can do is do this in order of operations. Okay, we can look at this and say, okay, well, this is minus 2.539, so negative 2.539 times 10. And then we're going to divide that by the square root of 20. And then we're going to add the 110. Okay, so let's take a look at that number. Okay, so we can say that the lower bound is approximately 104.3. Okay, now let's find the upper bound. So the upper bound is x bar plus the critical value times the standard deviation over the square root of n. So we have 110 plus 2.539 times the standard deviation divided by the square root of 20. And so putting that in the calculator, just like we did earlier, we're going to get approximately 115.7. Okay, now that we have the upper and lower bound, let's go ahead and summarize this. So we can say that a 98% confidence interval about the mean is between 104.3 to 115.7 if the sample size n is 20. Okay, now what we want to do is we want to be able to construct a 98% confidence interval about the mean if the sample size n is 25. So again, what do we know about the sample mean? We know the sample mean is equal to 110. We know that the sample standard deviation is 10. Okay, and we know that the sample size is, in this example, 25. So now we need to find out what that critical value is. Okay. So in order to find the critical value, we already know the fact that T alpha divided by 2 is what? We don't know what that is, but we still need to know that the percentage is what? Well, coming back up here, we know that this is already given for part 2, because we need to find 100% minus 98% to get 2%, which is converted to 0.02. And we know that we have 0.02 divided by 2, where we'll find the area right to the right of 0.01. So that remains the same. But now, when we look at the degrees of freedom, okay, that's equal to n minus 1. Now our sample size is 25. And when you subtract 1, we get 24. So now what we want to do is go down and look for 25 with an area of 24 with an area of 0.01. So let's take a look at that here. So we have 24 with an area of 0.01, and therefore we get a critical value of 2.492. So what that says now here is that our critical value for this sample size is 2.492. Okay, so now let's go ahead and find the lower bound and upper bound. So remember, the lower bound has a formula of x bar minus the critical value times the sample size over the square root of n, the standard deviation over the square root of n. And the upper bound is the sample mean minus the critical value times the sample standard deviation divided by the square root of n. So over here we know we have 110 minus the critical value now, which is 2.492, times the standard deviation, which is 10, and we're going to divide that by the square root of 25. Okay, so now that we have that, we know what our lower bound is going to be, and our lower bound is going to be approximately 105.0. Okay, and then the same thing here with the upper bound. We're going to take 110, and now we're going to add the critical value of 2.492, multiply that by 10, and divide that by the square root of 25. And therefore, our upper bound is going to be approximately 115.0. So if we summarize this, we can say that a 98% confidence interval about the population mean is between 105.0 to 115.0 if the sample size n is 25. Okay, now the next question is asking us to compare the results to those obtained in Part A, 104.3, 115.7. how does increasing the sample size affect the margin of error? Well, look at that. Look at the sample size. It went from 20 to 25. This went to 104.3 to 105. And this went to 115.7 to 115. So what it's saying here is that as the sample size increases, the margin of error is going to decrease, because now this is becoming closer and closer to each other. Okay, next. In part C, it says we want to construct a 99% confidence interval about the mean if the sample size n is 20. Okay, well, let's go ahead and write down the information that we know so far. We know that the sample mean is 110. We know the sample standard deviation is 10. Okay, and here we know that n is 20. And now we want to find is the critical value of t. So just like we've done before, okay, we know that this is 99%, so we want to find alpha. So alpha is going to equal 100% minus 99%, which gives us 1%, which is 0.01. So t now, alpha is going to be 0.01, and we divide that by 2. Well, 0.01 divided by 2 gives us 0.005. So what that tells us is that now we have a critical t value that has an area of 0.005, and we want to find out what is that critical t value. Okay. Now we also need to know that the degrees of freedom. The degrees of freedom is using the sample size and subtracting 1. Well, our sample size is 20 and subtracting 1 is going to give us 19. So now let's go ahead and use our table. 19 degrees of freedom with an area of 0.005. So, okay, so now we got 19 with an area of 0.005. So we're going to go through 19 there, and then the area is 0.005. And so therefore the critical value is 2.861. So the critical value here is 2.861. Okay. Now let's go ahead and now determine what our upper and lower bounds are. Okay, so recall that our lower bound formula is taking the mean and then subtracting the critical value times the sample standard deviation divided by the square root of n. And the upper bound is taking the sample mean and then adding the critical value times the sample standard deviation divided by the square root of n. So we know we have 110 minus the critical value, which is 2.861, times the sample standard deviation of 10 over the square root of the sample size in our problem, which is 20. So we get a lower bound of approximately 103.6. And then for the upper bound, we take 110 plus 2.861 times the standard deviation over the square root of the sample size of 20. And therefore, we get an upper bound of approximately 116.4. So when we summarize this problem, we can see that a 99% confidence interval about the population mean is in between 103.6 and 116.4 if the sample size n is 20. So let me go ahead and move this down just a tiny bit here to create a little bit more room. Okay, similar to the last part in part B, okay, we wanted to compare these results obtained in part A. How does this increasing the level of confidence affect the size of the margin of error? Well, again, as the level of confidence increases, the margin of error also increases. Okay, now in part D it says, could we have computed the confidence intervals in parts A through C if the population had not been normally distributed? Well, the student T's distribution requires the population from which a sample was obtained follows a normal distribution. So no, the population needs to be normally distributed.